We're going to do some microservice implementations so that the web application can show the rankings grouped by topics. So first, let's use a config parameter on the microservice that will configure how many records to show on the rankings. Just like we did before, we're going to create the config parameter, give it a value of 3, and move it to the config folder, and a wrapper function to abstract its access. Now let's create a helper that will return the rankings by topic. And the ranking is going to be a list of games with a score bigger than 0. It's going to be ordered by score and the total elapsed time as the second order criteria. So let's create a new function, call it getRankingsByTopicsID, and it's going to return a list of games. And as the parameters, we're going to have a topic ID, and the number of the results is going to return. We're going to use the transformation we previously built, transformation game with topic, and return all the games with the same topic ID as the parameter. Also, the score is going to be greater than 0, and total time is not null. That's the condition. That means that the game is not yet over. As for the ordering, we are going to first use descending on score, and as the second criteria, it's going to be ascending on total time. In here, we will get the best scores with the minimum time on the top. And the last parameter of the functions will be the limit to keep the result of the rankings configurable. The last modification we're going to make in the microservice will be to create an endpoint that will return the rankings. This ranking is a list of games by topic, meaning a list of games. So let's create a getRankings API. It's not going to take any parameter, and it's going to return a list of games. These internal lists are basically the rankings by topic. So the whole return list of lists are all the rankings by all the topics. Now for the routing, we are going to be doing a get request. The implementation is very short. First, we will return the list of topics, and then we're going to iterate on that list to obtain the rankings by topics and add it to the list of lists. And when we finish the iteration, we are going to return all the rankings we have stored. So we create a variable called rankings by topic of type list games that will be storing the results of each ranking for each topic and using the maximum number of entries. So create a variable to store all the rankings and do a push if the rankings value is not null and has at least one entry. Finally, we return the rankings compilation. Now we're going to start designing the components rankings by topic. But before we do, we need to create a new type called ranking item that will have the position in the ranking associated to the game. In the component ranking by topic, we're going to have a field that will show the topic name, a grid and the elements of the type ranking item. First, we will erase the initial label, and then from the root of the container, we're going to set a large vertical separation. We're going to drag a field widget, and we are going to name it field topic name, size large, bold, and centered. Then a grid named grid ranking, which we are going to configure using the wizard. Option start configuration to set the type to the grid and the columns to show. We are going to choose the position, player name, and time. Finally, center all the columns, of course. This component is going to receive a ranking by topic, meaning a list of games. So we are going to create a model variable, and we are going to call it instance of type list of games. First, we will create the main init function that will be in charge of visualizing the topic name and fill the grid with the rankings. Since all of the elements of the list have the same topic, we're going to get the value from the first element of the list. From the property topic.name. And set it on the field topic name widget. Now we are going to create a list of ranking items to load onto the grid. And we could perfectly ask the question, why did we create the ranking item type? And this is because the microservice returns a list without the position in the ranking explicitly, but it is implicit in the place on the list. So we need to do a little bit of work to create the ranking item lists and to assign the positions while we do. So create a game type variable that will be the temporal storage for the rankings we have on the model. We also need to create a variable of type lists of ranking items and another of type integer that will serve as the position value. We add a ranking item to the rankings with the position and the game, and we increment the position value on each iteration. And finally, we do a set value on the grid with the ranking list we just assigned. Now we need to create a render column function that's going to modify the position that appears in the grid to the icon with the cup, symbolizing the gold, silver, and bronze in the first 3 positions. So just like the last render we did on the positioning column of the grid, we are going to assign a keyword, in this case position. Now add an event function, render column underscore position, and move on to implement the logic. We're going to create a variable of type render column result and another of type ranking item that will serve as the received register, an icon for the first 3 positions and a text for the others. This way we can change the value of the config parameter and still show more positions without fear of running out of icons to show. We're going to use a switch blocky that, given a position in the ranking, sets a corresponding icon value. And for the default case, which mean all other cases, we just convert the value of the position to a string. And then we fill the result with either the icon or the text, returning the result. We are going to use another render column to transform the elapsed time to a human readable version, just like we did on the other previous component. We select the total time column, edit, assign a key, total time. Now create the render column underscore total time event function that will implement the logic, which only consists of calling the helper we built before and return the text in the render column result. the helper we wrote is the getFormatedElapsedTime. Finally, we are going to make some final changes to the design so that the column names can be better rendered. Now let's wrap up the development of the web application by finishing the CmpRankings component. Just like many others before it, the layout will be pretty similar, meaning the icon, the title, and the grid on the second container. But instead of the grid, we are going to use another widget called repeater. Since this process is basically the same, we're going to fast forward to do most of the same building. Now for the root container, we're going to use a large vertical separation, large top, left, and right padding, rounded border on the first container. On the second container, an icon with the value ranking.svg, size extra large, large padding on the top and the left. Now the title, ranking, bold, size large, left padding large, and use the dock to previous to latch onto the icon. And don't forget to make a rounded border with the shadow for the second container. Now for the part that is going to be different, instead of dragging a grid, we are going to use a repeater. This widget basically repeats a component as many times as there is items on a list. So let's select the second container, and we are going to drag the repeater and name it repeater ranking. In the UI component, on the details, we're going to select the component to be repeated, which is going to be CmpRankingByTopics. That's the last component we just built. And after that, we can see a preview which coincides with the repeated components. And now through the UI component binding, we can establish to what variable of the child component the repeater must send the register. And as we can see, we only have the instance variable as the option, which is the only variable we created on the CmpRankingsByTopic, and that's where the register will bind, which is written as curly braces record for the complete register. If we had other variables defined in the parent container, meaning CmpRanking, we should see them here as well. And finally, for some styling, we're going to set a large vertical and horizontal separation, and we are going to make the card sizes 4 out of 12. The border of the card with a radius, shadows, and all the properties to true. Finally, the CmpRankings logic. We're going to create a function where we will establish how the repeater data will load, and that is going to be the underscore load record event for that repeater. Just like the grids, this event will return a list of something, which are the entries of the widget to display. In our case, we will return the getRankings API from the microservice, which, as we already know, will return a list of rankings by topics. The repeater will take each element of the list and send it to the component through the instance variable. That's the variable we selected on the last step. At this point, the instance will be a list of games. And finally, the main init function will call the refresh blocky to trigger the load records event and have everything displayed. Once we are done with the development, we are finally ready for the testings of these components. and actually to wrap up the entire web application. But before the test, for better design, we will eliminate the borders we added to the container where the repeater is included. So now we are going to modify the presentation times for the quizzes to make the tests go faster. So let's run the solution. Let's see both the web frontend and our mobile application. And we can check that there are no games played. And so the rankings are currently empty. So we're going to fast forward a couple of games with different users and topics to see how it all behaves. We play a game. We can see the list of games played already has one entry. If we go to the ranking, we can see the topic general knowledge already has our game. Now we play another game with the same topic. And if we stop halfway and do another query of the realized games, we can see that the current game is not on the ranking. Once the game is done, even though we took longer, we have obtained a higher score. So we should be first on that game. So we refresh the ranking and we can see that we are. Let's change the player name for Jane and play again in general knowledge. And finally play a fourth game to check that only 3 results may make it to the rankings, just as we configured on the config parameter. Since we have no score, it won't appear in the ranking, not because of the 3 result limit, but because the score was 0. And we have a filter that this score must be bigger than 0. So let's play another game and get a score. And since we have the application, we're gonna cheat a little bit and check for the result of the last question. So we find that the answer for this one is gorilla. If we refresh the rankings, we can see that the last game is second, because even though we are tied with the first, we took longer times. And we can also check that only 3 of the entries get into the rankings. We are also checking that the repeater is displaying correctly with all the columns. We did the icon and the time, the double order criteria, and the max result limit. We're going to keep playing with different users and topics to see how the repeater shows different rankings by topics. In here we can see a display of the rankings using a repeater that repeats the component, which in turn have grids, which makes calls to the microservice. So right now we should be pretty happy. We have proven our entire web application is working correctly. And at this point, all of this actual solution is working correctly. The mobile application, the microservice, and the database.